Welcome to the fourth video of this kinematics series. We'll be looking at problems relating to motion with constant acceleration. So in this scenario, a motorcycle accelerates from 15 meters per second to 30 meters per second in 7 seconds. And we're being asked to calculate, first of all, acceleration and then the distance traveled in that time. So the first thing that we want to do is list all of the information that we know. So what have we been given? We've been given our initial velocity, which is 15 meters per second. Our final velocity, which is 30 meters per second. And we've been given time, which is 7 seconds. Now we want to have a look. We're also asked for acceleration. So now we'll have a look at the list of formulas that we've been given. So constant velocity, we're not going to want to use this formula because we're asked to calculate acceleration and this formula doesn't have acceleration included in it, so it's not helpful to us. Having a look down this blue list, our first formula also doesn't include acceleration. Having a look at the second formula, I'm seeing that I've got 3 of the 4 variables in this formula. So I've got final velocity, initial velocity, and time. And there's only one unknown, which is acceleration, which is exactly what I'm looking for. So I can use the values I've been given to rearrange this formula here to find acceleration and solve the first problem. So using this formula here, I'm just going to go ahead and plug those values straight into the formula. So acceleration is going to be final velocity minus initial velocity over time. 30 minus 15 is 15 over 7 seconds is going to give me 2.1 meters per second squared. Is my acceleration there. So that one's quite easy. I think the hardest part of that problem is actually just figuring out which formula to use. And part B, we're asked to calculate the distance travelled in that time, so the 7 seconds. And again, I think the hardest part of this problem is just figuring out which formula to use. So we're being asked to find x. This formula for constant, assuming constant velocity, is still not going to help us because it relies on us having the initial position, which we haven't got. Again, the first formula is not helpful. It doesn't contain anything to do with position. We've just used this formula and it doesn't contain position. This formula here and this formula here both contain position, but this one's going to be more helpful, this first one, because it's already in the format that we want. We don't have to rearrange it to isolate x. So that's the formula we're going to use. And again, I'm going to go ahead and plug those values straight into the formula rather than just copying it out. So distance is going to be equal to my initial velocity of 15 meters per second multiplied by time, 7 seconds, plus half acceleration, 2.1 times time squared, which gives me a value of 156.45 meters. But I want to be careful here now because that's the value that my calculator gives me, but it's not actually expressed to the correct number of significant figures. I have got 5 significant figures in this answer, but all of the values given to me in the question only go to 2 significant figures. So I'm going to want to do some rounding in this question. So to have 2 significant figures, my cutoff is going to be here between the 5 and the 6. And because I've got a 6 on the right hand side, that means I'm going to be rounding my 5 up. And my final distance travelled is going to be 160 meters.